anyone who comes in after this, we're going to make fun of them anyway. So good morning. Good morning. Even brought my clothes with him. It's the day after the day before. We're here. We're not happy about it. I'll try to make it as painless as possible. My name's Adam Backman. A lot of you know me already. Anyone who doesn't know me, they're probably sitting right here in the splash zone. But I work for a company called White Star Software. We specialize in the back end of progress. We do performance and monitoring. And I'm not going to talk about that today, but I am going to talk about building hardware. And I don't think of resiliency or reliability differently than I think about performance. I think when you make a decision, you're making a decision to do both. You need it to be reliable. That's got to be job one when you're purchasing anything. It has to be reliable. I have to be able to depend on it. And if it doesn't perform as well as you need it, then you failed just as much as if it wasn't reliable, because people don't trust you. They're not going to trust your judgment. They're not going to trust you to make a decision the next time to do the right thing. So you need to think about both. This is some marketing thing. Sorry, Louie. What we're going to talk about is performance and reliability, but I'm really just going to talk about both because you have to choose both every time. One of the things that people don't think about when they're buying hardware is they don't think about how much you're going to save over the lifetime by buying the right thing in the first place, by buying your maintenance up front, by doing everything that you can to buy the most reliable and the fastest hardware you can afford. And it's where you spend your money. We find lots of people spend their money on CPUs when it's really a disk problem. So spending your money properly. What makes it up? The system's made up of the same stuff it's been made up for years. Your network, storage, memory, CPU. It's easy. Virtualization doesn't make hardware magic. I can't commit resources with virtualization and expect to get good performance. So remember that the laws of physics always apply. And I can't go out there and allocate 40 CPUs when I have 8 CPUs inside the machine. So let's be very cognizant of that. And we'll talk a little bit about doing this yourself or outsourcing it, because more and more people are going to hosted environments with AWS or something like that. And I want to talk about the decisions you make there as well, because a lot of people, they go, oh, they'll take care of it for me and I'll just allocate more resources. But there's things that can bite you in that environment as well as in your own hosted environment. All of the things that we worry about performance, but the biggest thing that we try never to talk about is this application efficiency, because it's not my job. I'm a DBA. But ultimately, it is your job to point out those portions of the application which are causing poor performance. So you need to be able to push back either to your own development environment or to your vendor. You need to be able to say to them, this is the part of the application that isn't working for me. Database design and layout. Use all of your resources. I want you to use every resource you have inside the box as evenly as possible, because that's going to yield you the best performance out there. So we'll talk about all of this stuff here. This is the single largest factor. If you have an application that's coded poorly, you're going to have, I don't want to say bad performance, because you can hide a lot of bad performance with hardware. I can hide a lot of bad performance with a bigger buffer pool. I can hide a lot of bad performance with a lot of CPUs. But ultimately, I need to push back on that. And it's the single largest factor. It has way more say than my hardware purchase. Because I know that someone's going to write worse and worse application software until they overcome my ability to compensate for it with the hardware. This is use indexes. There's so many talks about using indexes, but use the ones you have. Don't have too many, just have the right amount, and that's hard to say. I need to go out there and look at how I'm using them with VSTs to be able to make good decisions here. I want to get rid of data bottlenecks. And I did a tuning gig a long time ago, and they had one thing that was causing them an issue, and it was they had a hotspot in their database. And that hotspot was new every day, because they go out there and they'd have a hotspot on the very last block that they were updating. Because what they would do is that every time they inserted a record, or every time they changed a record, instead of just changing it in place, they would delete it and then add it again, so that we'd have this very hot block right at the end of the database. When they eliminated that one thing, they went from not being able to scale past a couple thousand users to being able to scale over 15,000 users. So that's a huge difference, and it was one change they made inside that application. Move your reporting off. So if you're using replication, push that stuff over to your replicated database, because it will make a huge difference. And people found this out where you guys just had this at Dimension, and what happened there was they started replication, and then they said, well, why don't we just move some stuff over there? And they found out the blocks for the OLTP users were staying in memory, and their performance increased a great deal because they were never flushing them out with old, horrible blocks. So that's a big deal. Database design and layout is, we used to think about this a lot more than we think about it today, because we're spoiled. And the reason we're spoiled is we have solid state disk. And solid state disk hides a lot of problems. And I hope that everyone here is running solid state disk. It's 2024. If you're not running solid state disk, you are behind the curve. So it's really important we do that. A big BI cluster size. The default BI cluster size is too small. Increase it, make it big. You don't want to have too many checkpoints. Every time you fill that cluster, you're doing another checkpoint. So we want to get that out. Always use type 2. Anyone who's not using type 2 is behind the curve as well. So we've had type 2 areas for a long, long time. So you need to take advantage of them. It is universally better for performance. It is better for performance every single time to use type 2 over type 1. Why they don't have it as the default, I don't know. But they need to. That's really important. And just remember, when you increase your block size, you may need to increase your records per block. Speed. You have to start talking about, the best thing is to not use the slowest resource. So if you can get off the network, that's better. So if I can get local, so reporting, I want to be as close to the database as I possibly can be. I don't want to be doing it client server, because that's going to be utilizing the network, which is the absolute slowest resource we have out there in the environment. I don't want to be using the disk. I don't want to be using storage. That's why I have a big buffer pool, so I don't have to go down and hit it as often. The ideal is to minimize these slow resources and maximize this and this. memory and CPU because those are much faster. So we want to make sure we do that. We'll talk about virtualization, what you have to do with virtualization and in hosted environments. Distance matters. Your time, when you do a ping time on things, Tom did a bunch of testing on ping times and client server access, and he did a talk yesterday. We sang him happy birthday. But he has been testing client server performance for years and years. And if you're not on 12, you're not getting the best network performance you can get because there are so many optimizations they've done in version 12 that make it more palatable to be client server. But he did one test. He was testing in various things. So he did a client server test from the airplane. And we've been talking about the number of records per second you get on all these environments. But on the airplane, the ping time was 900 milliseconds. And the amount of time it took for records wasn't records per second, it was seconds per record. So if you're in these slow environments, these things become so much more magnified. You can use app servers to shorten your distance or reduce the amount of stuff that goes over the network, and that's a really good thing to do. So if you have multiple connections to your machine, which you should have multiple pieces of wire coming out of the back, and you should use all of that wire that you can. But you should use it intelligently. It can't always be everything's going for client server because I have other things that are happening out there. I have replication that's happening. So why don't I push that replication traffic to a different piece of wire? That will at least allow the wire that I'm using for client server to be less used and have availability for me. So being intelligent about that is really important. Also, when you look at the redundancy of this, you need to make sure that you have multiple routers in the loop. You have to make sure that you have multiple hubs that you're going through in the loop. If you don't have that, then you could flood the router, you can flood that environment. So I want you to be redundant that way. This auto negotiate used to hit us all the time, where you allowed your laptop to auto negotiate and it wouldn't go to full auto, it would go to half duplex. So you want full duplex, you want the fastest speed. I tend to just hard code it at the fastest speed. That way, if I ever have a problem, I'm gonna know right away because that client's not gonna connect. So if something in the middle causes that to slow down, I want mine to fail because I don't want to be in an environment where the thing works okay sometimes and not okay others. It either needs to work or not work. So setting it to the highest speed in full duplex is the best thing you can do. But no server out in your environment should have one network drop. They should all have multiple pieces of wire plugging them into the network, hopefully plugging them into multiple networks so you can always contact that piece of hardware. So it's really, really important. Storage. We're talking about all these things here. Database, before image, after image. The before image file and after image file are different than the database because their I/O is done synchronously. And there are places in the database that you will have to wait for a piece of BI to be written or a piece of AI to be written. There's no place in progress that you're going to have to wait for the database to be written. The database does a lazy commit, it just throws it over the wall and thinks it'll get there at some point, which it will, but that's how it works. The thing that people don't think about are log files and temporary files. Log files, especially if you've got tons of connects, you have tons of things that are going on there, you're going to write a lot of stuff to those log files, and they're actually going to be a significant source of I/O on your system. Temporary files are always going to be a significant source of I/O on your system. You can use them as performance levelers by spreading them out across the available disks, or you can allocate disks specifically for them to be fast on. But you need to think about that when you're building your system. Don't just think about the database. Think about how your application works. You may have output files that are critical to your application. You need to make sure you take care of that stuff. Okay, it's 2024. Is there anyone here running actual rotating disks? Hooray! This is the first time I've asked that question, and everyone in the room kept their hands down. You're either really good liars or you're doing the right thing. I'm hoping it's the latter. So, local storage is better for performance. The closer you can be to the machine, the faster the storage is going to be. That doesn't mean that using SAN storage is always bad. It doesn't mean that doing things on the network is always bad. It just means that you've made a trade-off. You've made a choice. And that choice is, I've chosen flexibility over speed. And as long as you do that with your eyes open, that's fine. But you don't want to say, I want the fastest machine possible, and then go put out a SAN. It's not going to be the fastest machine possible. So, RAID 5. I don't think I've ever said this in public before, that RAID 5 is okay. If you're running RAID 5, you're not a bad guy. You used to be a bad guy. You're not a bad guy anymore. And the reason, and everyone here is a male, so the reason that you're not a bad guy anymore is because the problem with RAID 5 is that you had to do 3 operations to get the disk to write, and they were blocking operations. Well, that used to block us for milliseconds. Now it blocks us for half a millisecond or a tenth of a millisecond. And the storage can keep up. Before, you would overrun the ability of the storage to keep up because of that longer latency with spinning disks. So it's really okay to do that. And people make the mistake of spending on CPU, but if you can't get the stuff off the disk, all the CPU in the world is never going to help you. So you really absolutely have to spend your money on the storage first. And the thing that nobody understands is that if I buy local storage, it's cheaper. It's much less expensive than buying a SAN because you don't have all the extra equipment out there that you have to buy to support a SAN. So doing this is really, it's okay, but make sure that in your budget, when you're buying things, buy the most important thing first. That's storage. You're in a database. You're not a web application. You're not something that it's going to put the page into memory and never ever go back to disk again. Every time you read, every time you have to do a physical I/O out there, which you're doing billions of times a day, you're hitting this resource. And this is the one that you need to spend your money on. Network storage. They provide way better failover options. I can do a lot of things with SANs that I can't do with local storage. They have great remote mirroring. There's nothing great about remote mirroring with local storage. So you're not going to have that. SAN distance really matters because the latency on that wire, if you've got a big coil of wire sitting next to the machine because it might move at some point, get rid of that and put the shortest piece of wire you can between your storage and your server because that will make a difference in performance. And again, it's not one I/O that I'm worried about. I'm worried about billions of I/Os. So if I'm a millisecond faster, billions of times, that makes up a huge amount of time. So you need to make sure that you're thinking about billions, not thinking about individual round trips. So this other type of storage is generally bad. Why is it generally bad? Anyone know? It shares infrastructure with your client server traffic. So this iSCSI or NAS is going to be on the same network as your client servers users are. So it's going to be using that unless you do something smart about that, unless you have a dedicated link back to that NAS or SCSI. But the benefit to you of buying that stuff in the first place was that you could just plug it into your network and it was there. But that's also its downfall, because now I have to contend with that traffic along with my regular client server traffic. So I generally try to avoid anything that shares my worst resource. I don't want to have multiple things contending for it. Memory. Buy what you need and use what you have. Those are the two things you have to remember. Everything else doesn't really matter. The one thing that you don't want to do when you buy memory is buy way more than you need. Because what happens is it gets used for these big file system caches. And those big file system caches need to be synced back to disk at some point, and that could cause a problem. So I tend to buy just what I need to support the environment, plus a little bit room for growth, and call it good. The only problem with that is if I have to go out there and make a large change in my buffer pool, I might not have the memory I need. It's a lot easier in virtualization because I can dynamically allocate it over to the machine as I need it, and that's an okay thing to do as well. CPU. Speed is the most important thing. Speed is absolutely the most important thing that you can contend with. Most people think, oh, I'm going to go out there and buy the 40-core Xeon processor. Great, you have 40 cores. But those cores are probably going at half the speed of something that would be an 8-core. How many cores do you need for progress? I don't know anybody out there who really needs more than 8 cores for their database server. We have some people who've got a lot more cores than that, and they're really not using that many of them. The bad part about having loads of cores out there is every blocking operation you do, every type of operation that is where you have to make sure that there's referential integrity, you have to ask 43 of your closest friends if it's okay if I do that, rather than having to ask 8 of my closest friends. So it's much faster to have less CPUs. So what we want is fast and few rather than many and large. So buy the speed, then buy the quantity. The next thing is NUMA. It's almost impossible to avoid these days. If you have multiple sockets in your machine, it's highly likely your machine is NUMA. And NUMA is, I just say, oh man, NUMA. We'll talk about NUMA to its death. I went out and looked yesterday. We had a client call us up a few weeks ago, and they said, we hate to bother you. And I'm like, you're my client. I don't think you're bothering me. But we need to ask you a question. Can you help us? And we said, sure. Can you help us buy our new hardware? Absolutely. And we gave this speech about fast and all this stuff. And they went out there and bought a Xeon Gold 6534. It's a lovely processor. How many cores does it have? 8. Notice it doesn't have 44. It has 8 cores. Look how fast those cores are. 4 gigahertz, 3.9 gigahertz. What we have is a little thing that tests how fast systems are. And we call it BOGO MIPS. And it just stands for bogus MIPS. And it's just a complete made-up number. But this is when they were running on AIX with the AIX chip speed, which is glacial. Right when they switched over, they got a little false positive, but they're keeping their MIPS rate, and they get a MIPS rate, actually that's a low rating. Most of their day is above 15. And that's blazing fast. It means that every operation they do is much, much faster. But what they noticed also is that their speed wasn't very quick. Know what they did the next week? they called us up and asked us how to buy hardware. Can you help us buy disks? Well, we should have done this the other way around, but at least they're out there looking at the problem, and they're going to solve the problem by buying faster disks. So this number is just to show what the dramatic jump in speed was going from an old platform to a well-spec'd new platform. So we want everybody to try to be up in that range. These are the processors that are coming out this year. Okay, 8 cores, base speed 3.5 gigahertz. But look at the drop off here. Look at the drop off for 44 cores. Your base speed, the turbo speed's great, but you're not going to run at turbo speed. You're only going to run at turbo speed occasionally. The CPU is not built to run at turbo speed. It's built to run at base frequency. So make your choice. Do I need more than 8 cores? Well, okay, I can buy a 22 core. I'm still getting a reasonable gigahertz out there. I'm not going out there and getting a very slow base frequency. So look at the base frequency. Don't look at the turbo. The turbo is a complete fuzzy number. And it's just a way for Intel to go, well, look, it's 3.8 gigahertz. Well, no, it's not. It's 2.2 gigahertz. It's not faster, it's slower, it's worse. So that's what you do when you look at resources. I say this is the best one you can buy. And the reason it is 3.5 gigahertz, that's the fastest inline speed. I'm never going to need more than 8 CPUs. So great. I know that that's going to meet my needs for a long time. So this is Dell's website. And you look at this, they have all these different choices here, but remember, you're buying this number. You're buying cores. You're not buying threads. Intel came up with this whole threads are equal to another core, and everyone believed them. But unfortunately, that's not the way they work. What happens is every instruction goes to the core, and if it happens to be a math instruction, it gets pawned off onto the math coprocessor, and another instruction can go through. But you might notice that Progress OpenEdge is a database application. So what are the majority of the requests going to the CPU going to be? Data. So you're not going to get a benefit on almost all of the requests you do. So when you're building things, don't think of threads, only think of cores. How many physical cores do I have available to me? When I build VMs, don't think you don't have 16 cores to allocate. And VMware is going to show you 16 cores. You don't have that, you have half. So when you allocate, you need to allocate based on physical cores. And you can't overcommit resources on VMware, because the second you overcommit, even if you don't have the machine on, it will affect performance. Because what happens is you get a different way of using the CPU. You get time sliced. So you get a portion of a CPU cycle, because VMware needs to reserve those resources in case that machine turns on. So if you have just built machines and you say, oh, we just shut them down, that doesn't help. They have to be inactive. You can't have active, because it has to reserve the resources. So it's really, really important. But when you look at this, look at which ones are really expensive, and you're going to find out that there's a lot of things that are more expensive, even in the small number of CPUs. But this is hard to read when you're going through there. But again, what you want to do is you want to go back and refer to Intel's documentation about that particular CPU. You want to find out the real number of cores that you have, buy cores, not threads, and you want to buy base speed, not turbo speed. NUMA. NUMA is just, it's the bane of my existence now. I get to talk about it probably weekly to somebody who purchased a machine and all of a sudden they found out that they didn't really buy one machine. They actually bought 2 or 4 machines. We had a client and they went out and purchased a machine without talking to us first. And they said, we want to run on bare metal. And we have disks that are really close. They did everything right in terms of the disk. They did everything wrong in terms of the CPU. So they went live, and all of a sudden, performance became variable. When they tested it, it was great. Because what they did is they ran a few threads at a time, making sure that they were getting speed through the database. And they were. They're getting massive speed. But as they scaled up the number of users, performance became variable. And what happens is you're going to see some things go through quickly, other things don't go so quickly. And the reason you see that is because you have something called far memory reads. So what we saw is we see this number really jaggy, okay? So we had some of those BOGO MIPS that came back, and they were doing near memory reads. So they're the ones at the top of this chart. Then we did far memory reads, and these are the ones that are at the bottom of the chart. So what happens with a far memory read? In NUMA, a socket is associated with a set of memory. And for ease of use, we'll talk about a 2-socket system or 2-node system. So half of this memory is allocated with socket number 1, and the other half is associated with socket number 0. When I allocate a database, I go out there and I say ProServe, and I grab a bunch of memory. If I grab less than half of the memory on the machine, it's going to put it all in one node because it wants it to be in one node, and I want it to be in one node. So it's doing the right thing. But as soon as you start scaling up the number of users, the users are going to start using the other node, and when they read, they have to go across the interconnect, and then they have to go into the memory that way. And that's 3 times as expensive as doing it locally. So every request I do locally is 1, every request I do remotely is 3. So that's why these numbers are so jaggy out here. And what we want to do is have a nice, reasonably straight line. You will see some variance, but if it's this jaggy, you know that you've got good IOs and not so good IOs. And I talked about performance being predictable yesterday or the day before, and that's what we want. This is not predictable. I can't tell if I'm going to get a good read or a bad read. It's just luck of the draw. So I don't want it to be that. So if you're on Windows, there's a check graphs, and then you can say NUMA nodes. If you're on NUMA, it'll allow you to look at that, and you'll see here, this is a 4-node NUMA system, okay? Because I got 4 windows. If it were 2 nodes. But this is what it looks like. All of this memory is associated with these CPUs. All of this memory is associated with these CPUs. But every CPU can address the memory on the other side. So what happens is, if I start the database and I use all of this memory, and most, the first 4, I have 4 processors, it's going to use those 4 processors. It's going to try to do things locally because the scheduler's trying to do the right thing. But as soon as I get busy, it says, oh, we should use all the resources evenly, and then it goes on to the second node. And that's when I start seeing anybody who's on this set of CPUs over there, they're going to get 1/3 the performance as these guys are going to get. And it happens only when you scale up. Because we've had plenty of people say, performance was great until it wasn't. And they thought, oh, this is just scaling pains where we added more users and it's causing pain that way. And it wasn't. That client that had this performance that was blazing all of a sudden became unpredictable. They wanted to run on bare metal. and they had a 4-node NUMA system. No, what we had to do? Turn off 3 nodes. We just turned off 3/4 of their system and made them not accessible. Their performance doubled. So with 1/4 of the CPUs, their performance doubled. And that's common in NUMA systems. So if you have performance that's variable, you should check if you're NUMA. If you're on VMware, it's easy to solve. If you're not, you have to turn off nodes. And your performance will get better. The one thing you can't do is I can't allocate all of the memory anymore. Because remember, this memory here is associated with this. Right when I turn this off, I only have half the memory. So NUMA can bite you in 2 ways. I can over-allocate in terms of the number of CPUs, but I can also over-allocate in terms of memory as well. So you need to remember both. What we did was we pulled a bunch of chips out of the other nodes and put them into the node we were running, and it seemed to work just fine. So the thing you're worried about is affinity. I want my CPU and memory affinity to be on the same node. And that means that I'm pinning them to the block of stuff that they have. VMware allows you to do this. I don't know about other virtualizations. I've not done it with any other virtualization, but I'm assuming it allows you to do that as well. But if that's the case, if that's not the case, you can turn stuff off at the hardware level in the BIOS. Getting this right means that you're not going to have those far memory reads, and you're never going to have the slow performance. So you're getting rid of all the dips on that chart. And when I say they're 3 times worse, it's actually worse than that. 3 times worse is the best case scenario. That means if I get a direct hit in memory, so it's already cached, then it's 3 times worse. If I have to go to disk, it's 10 times worse. So really, if you have a poor buffer hit rate, then all of a sudden this problem becomes really big, really fast. So we need to make sure that we have 100% CPU and memory affinity. Virtualization. Never over provision. That's the first thing. Even if you're not using the nodes, those nodes have to be actually inactive for you to reserve that resource. As soon as you can just turn them back on, VMware or the virtualization software has to reserve the resource for you. And if you have more resources allocated than you have, either you said, oh, those threads I have out there, as remember, VMware is going to show you threads, not cores. So if I go out there and allocate all the threads, I'm overcommitted. I'm overcommitted because the CPU, that math coprocessor benefit that I get, is only a 15% benefit. It's not a 100% benefit. So what I do when I'm allocating for VMware is I allocate all the cores, okay? So all the hosts I have on there, I use all the cores, but I don't use any of the threads at all. If I have greater than 8 CPUs, if I have 16 CPUs, I allow VMware to have all the benefit of the hyperthreads. Pardon me. And that's really important. So VMware is not free. Virtualization is not free, but it doesn't have to cost you a whole CPU. You can just have it use your benefit of the threads. So it will affect performance. And we've done testing with this of just allocating machines and not starting them up, and we saw performance drop off. So it's not made up. This has been tested, and don't thin provision anything. Thin provisioning says, oh, it's okay. We don't have to give you all the resources you asked for. We give you some part of that. Well, I don't want my production system ever asking for resources. I want it to demand resources and have them there when it needs them. So make sure you thick provision everything. Physical cores are the only ones that count. I can't tell you the number of times we go in and people go, oh, I got 38 VMs on this thing. And it's like, really? Well, it says here I have 64 threads. You do, but you only have 32 CPUs. So you're overcommitted. There's no way you're not overcommitted. So make sure that you only count those physical cores. That's the core benefit. I've drawn this on napkins across the world about how this works, but it's basically just a pipeline optimization, and it only gives a little bit of benefit. So, the NUMA problem. VMware has NUMA control section, and that means I tell it where to allocate stuff. The only negative to allocating it to a node is if you had a hardware failure. And you'd have to have the weirdest hardware failure ever. You'd have to lose a CPU. The likelihood of you losing a CPU is as close to zero as it can be. So I don't really worry about that, but remember to do both the affinity for the CPU and the memory when you're doing the NUMA allocation out there, and that will give you optimal performance. You're only going to use one node, you'll never have a far memory read, and it'll work much, much better. But it does limit you to the amount of memory on a given node. So if you have 4 NUMA nodes, you have to divide by 4 to figure out how big your buffer pool can be or how much memory you can allocate to that host. Pardon me. A lot of people go into AWS or Azure or place name here, and the same rules apply. They're using the same boxes that we're using in-house. They have NUMA problems too. So the good thing is, by default, they're gonna put you in the proper NUMA zone. They're actually gonna zone you into the right thing. When you say, I'm building a database, because it says, no, databases don't want to be in NUMA, so I can give them that. But I have to figure out where those limits are because it's not obvious. So we had a client that did this, and they were running with 32 CPUs. They have all their clients are local, okay? So they had a lot of CPUs for that. They said, well, we could use a little bit more CPU to give us some headroom. And they went out there and allocated 4 more CPUs. So they had 38 CPUs. And then their performance became variable. And we said, I wonder if that's a NUMA zone problem. Right when we did it, we found out they had 2 NUMA zones. So they could go up to 32 and they never had another zone. The 33rd one said, nope, now you're NUMA. So they have a limitation from their vendor that they can only go to 32 CPUs, which is probably more than they need anyway, but we crossed the NUMA boundary. The other thing that we found is that we go out there and plunk something out. Azure really has this problem. AWS has this problem less, but not zero. But when I allocate machine 1 out there, in the US, we've got 10 zones or something, or 20 zones. So I'm going to go to 20 different COs. One's going to be in Atlanta, one's going to be maybe in California. When I allocated the first one, it put it in Atlanta. Then I go out there and I allocated another one, they put that one in California. I have to ask for them to be proximate, okay? So they have proximity zones, and if you do that, it'll always keep your machines together. So even if it fails and you go to a different zone, it fails both over at the same time. The difference in performance is because of the distance on the ping. You know how I said network distance matters. Well, if I have one CO in Atlanta, one CO in California, then that's going to be a long ping time. So as long as you keep them proximate, then you're going to be in good shape. It makes a huge difference. And we found out that it was like a doubling of performance by keeping them together. Spend your money on storage first, then everything else. Buy fast CPUs and few CPUs because they're faster, and use what you have. No single point of failure. The network is the place that I find the greatest number of single points of failure out there. And I can tell you that more than once, probably more than many times, I've had someone go out there and say, oh, we put a Cisco update on, and now we can't see anything. So they went out there, they put one Cisco, they upgraded one router, and it just turned off their network. And it's like, well, if you had two networks, you wouldn't have that problem. So really, it's important to be redundant at that level. Buy the amount of memory you need. Don't overbuy because you don't want to have that huge buffer pool out there, the huge file system buffer pool. And redundancy is not optional. Everything has to have another one allowing it to do the work. So if something fails, the other will take over and keep going. I want to be able to persevere through problems, and that means making sure that I have redundancy. Never, ever, ever overcommit resources. Only use the cores, not the threads. And remember, if I use all of the cores out there, I've left no cores for VMware. Okay? So generally, I like to leave some cores for VMware if I have a lot of them. But I don't necessarily say you can't completely commit all of your cores to VM clients and then use the overabundance that you get from the optimization of threads to run the VMware stuff. It'll probably be okay, and it won't reduce your CPU time. It won't go out there and time slice you. So you can go all the way up to the cores without getting time sliced. Right when you overcommit on the cores, it'll time slice you, and that's every single request you do. Everything still applies while hosted. Make sure that you're not NUMA. Make sure that you have enough memory. Make sure that you have the fastest disks you can have, and worry about your disk speed before your CPU speed. You can allocate more CPUs later easily in these hosted environments. So make sure you get the disk right first. Questions? Comments? Personal problems? No, I don't want to hear personal problems. Thank you very much. If anyone has any questions, I'm here for questions. I'll be around today. I'm happy to answer questions, or you can contact me at adam@wss.com. It's the first slide, and these slides will be posted. Thank you very much.